Hello and welcome to T3 Day 20 of Honors Precalculus. We will talk about statistics and data today. So first we're going to start with three words you might have heard of before: mean, median, and mode. The mean is a set of a set of numbers is also known as the average. So this is the thing we think of when we think of an average. We add them all together. If there's n elements, we do the sum divided by n. You'll notice that this is notarized by x bar. That means the average, which is the mean right there. The second word, median, of a set of numbers is the middle number when you order them from smallest to largest. And if there are an even number of numbers, then you find the average of the two middle numbers. So you list all the numbers out, you cancel them out one by one, and whatever the middle number is, that is your median. And if there's two, you do the average of those two. The mode of a set of numbers is a number that occurs most often in the list. Another way to represent a set of numbers or statistics is in a back-to-back stem plot. And what you see here is year. So this is the year right here, 86 all the way through 2001. We're talking about two rather shady people. And these are the number of home runs they had. They got a lot of home runs. We can talk about how that happened too in class. The stem is the first number in the output. So for example, in 3 right here, the first, it's actually a two-digit number. The first would be 0. So that's 03. This is 0909 right here. So when you fill in this set here, when you fill in this back-to-back stem plot, let's look at Mark McGuire here. There are 3 numbers that begin with 0, 03, 09, 09. So what you do is you list all of those out right here. So it's going to be, there's a 9, a 9, and a 3. They all begin with 0. And are there any for Barry Bonds? There are not. What about starting with 1? There's nothing for Mark McGuire, but if you look here for Bonds right here, you have 16, you have 19. Are there any others? There are not. So what you put on the other side, you put a 6 and a 9 right there. And you do the same thing for all of the other the second digits for each of these. So 2, and I'll fill the rest of these in. You end up with a back-to-back stem plot that looks like this. So one thing to point out here is you can kind of see down here, this represents 70 home runs for Mark McGuire and 73 for Barry Bonds. You have the 73 right there, you have the 70 right there. So those two outputs, they are called outliers. These would be outliers, the technical outliers, the technical definition being a data point that is not representative of the other data points. So there's mathematical ways to do that, but you can also see these are kind of outliers. They stick out. So you could use a calculator to find the mean and the median of each. Remember, the mean is just the x bar, the average of all of them. So you would add up everything in this row and divide by the number of representative, how many numbers there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you do the sum divided by 16. And then the median, from your definition above, is the middle number, So you put them in order and then knock off the numbers at the end to find the median and mean. So I'll let you do that. All you need to do is you need to add together all of these numbers and divide by 16 to find the mean and the median, put them in order, and then start knocking off the first and last, the first and last, the first and last, and what is the middle number. If there's 2 in the middle, you average them. So here's another way to represent a set of data. A teacher gives a 10-point quiz and records the score in a frequency table as below, meaning this is the number of times someone got that score. So there are 2 people that got a 10, there's 2 people that got a 9, 3 that got an 8, etc. And you can use Excel. We're going to do this in class. You can use Excel to make a histogram. This is the histogram. So this tells us that there's 1 person got a 0, that's over here. That would be this number right there. 1 person got a 1, 1 person got a 2. So these first 3 are right here. And it shows us visually that the most common one, the mode would be a 7 right there. So you can use this to see it, and then you can find the mean, median, and mode of each one. When I say each one, I mean the data set. So you can clearly see the mode. The mode is the most common one. That's going to be 7. And then the median is going to be is 6.5, and the mean is 5.93. So you'd add all of these two things together. So when it tells you that 2 people got a 10, you would do 10 plus 10 right there, and then 2 people got a 9, you'd add 2 9s to it. You do the whole sum, and then you divide by the number of test scores. There's 2 plus 2 plus 3 plus 8 plus 4 plus 3 plus 3 plus 2 plus 1 plus 1 plus 1. That would be the total number, and that would be your X bar right there. That would be your mean. Now the median is the middle number. You'd list them all out, you'd cross them out, And what happens is you end up having to take an average of 2 middle numbers, and you end up with 6.5. And another key thing to know is that the median and the mean are measures of central tendencies. It's just a good thing to know. So going back to this, for example, histogram, the best way to do this, because each of you is going to have a different version of Excel potentially, we're going to do this in class. You can also Google and find on YouTube lots of ways to make a histogram. You're going to have to type in the data, but then you're going to insert and go to Histogram Charts. We'll do that in class, but feel free to play around with it on your own. So at Marty's school, it is an administrative policy that the final exam must count for 25% of the semester grade. If Marty has an 88.5 average going into the final exam, what is the minimum exam score needed to earn a 90 for the semester? So to get a 90, what would it be? Well, 0.75 of the grade is from the 88.5 points that the person has earned. And then the final exam is 25%. And we don't know what the test score is, but that added together needs to be 90 right here. Needs to be 90. So you can kind of think of this is what's not the let's go with better color there. Not the final exam right there, and that's the final exam. Together that better be 100 because that's the whole grade. And that takes out the 88.5, and this is the final exam grade. So when you solve for X, you end up with 94.5, and that's percent. So to get that 90, you would need at least a 94.5%. But again, this is not the final, this is the final, how much it's weighted, and then that's what's the average on the not final, and then that's the score of the final. So let's find the mean, median, and the range of these, which is the difference between the minimum and maximum. So when you do this out, you add these all together, and then to find the mean, you would do the sum of all of these, and then you divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. When you do that, the mean turns out to be 82.18. And then to find the median, what you do is you list them all out in order. So you list them out in order, and then you start eliminating there, high, low, low, high, low, high, low, high. You end up with 87 right there. And then the range is going to be the lowest to the highest. So that's going to be 94 minus 33, which is 61. Keep in mind that it didn't say eliminate outliers, but 33 would definitely be an outlier, and it definitely influences things greatly. So if you do the same thing down here, you end up with a mean on this one of 78.54. You add all of these together and then divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then if you list these in order and cross them out one at a time from each end, the median is going to be 76. And then the range is the lowest to the highest. The lowest to the highest on this is 38. And on this one, there is no definitive outlier. Similarly, you do the same work and you end up with this. And what you can tell for the second part of this question says which measure of central tendency. So that's the median or the median or the mean here. Either one is fine here on these. Either one is fine. You can tell that because they're really close together. On the first one though, the median would be better. The median would be better because the mean is greatly influenced by this outlier right here of 33. That 33 doesn't really change the median. It doesn't change the median that much, but it does change the mean, which is the average. So measure of center only tells half the story. That's mean, median, and mode. We need to describe the spread of the data. When the median is the best way or a very good way to describe the data, we'll use 5-number summary. So just like the median separates the data into halves, quartiles separate it into quarters. So there's 5 numbers here. There's going to be the minimum value, there's going to be the maximum value, and there's going to be the median, which we can find directly. Q1, which is quartile 1, which is the median of the lower half of the data, and Q3, quartile 3, is the median of the upper half of the data. So let's say we had this data set. The first thing you have to do is list this out in order, and this is why Excel is really nice because you can type these in and then sort it, but if we do this by hand, it ends up like this. You end up with the 16 numbers in order like that. Each one could be repeated. So what's the minimum value? That's our minimum value. And where's our maximum value? Right there. So we can note those down. And what's the median going to be? What's the middle number going to be? The middle number of this is going to be 11.5. And we do that because these two, there's an even number. What's the average of 11 and 12? Because that is 11 plus 12 over 2. There's our median right there. And remember, we need quartile 1 and quartile 3. Quartile 1 is the median, the middle of the lower half of the data. So the lower half of the data is right here. So what's in the middle? 10 is in the middle. So quartile 1 is 10. And then quartile 3 is going to be the middle over here. But there's two numbers there. So it's 12 plus 15 divided by 2, which is 13.5. That's 12 plus 15 divided by 2. So these 5 numbers are super important. And what you know is that between quartile 1 and quartile 3, 50% of our data lies between 10 and 13.5. So again, 50% of our data lies between 10 and 13.5. And here's another data set. Find the 5-number summary for the male and female life expectancies in South American nations. Do the males by hand and the females using your calculator, or do both? Whatever you'd like to do, that's fine. And let's see what this data comes out to be. So the first thing you have to do is you have to list each of these columns out in order. You can use Excel to order them, and then you need to break them into quartiles, so the 4 spaces, and use the 5 numbers. This is what it looks like when you're done. So here's what it looks like when you're done. So you can get the min and max pretty easily, and the median pretty easily, and then you have to do the same thing for quartile 1 and quartile 3. Just take it slowly, and as a hint, you might be able to do this on your calculator completely. So you should poke around, see what you can do, but it's good to do it out by hand so you know where these numbers are coming from.